RESTCONF and also REST API. So when these RESTCONF or REST API can be looked after, you can say that these both belong to the same category, and there is just a slight difference between both of them. Otherwise, the entire architecture is quite same, and the devices against which what protocol will be executed. So for now, what we have been doing is we've had PC, and that PC will go on to a specific device, and it has been in our case as iOS XE device, and then you can deploy some configuration onto this XE, right? So over here we basically use some Python script, right? And then in that Python script we write down our XML, which is nothing but our payload, and then we have our connection, and then our query, whether to get config or edit config. That's how things have been so far. Now, in this architecture, if you look at the protocol that we have been using, it was NetConf, right? And in NetConf, if you look at the protocol stack, then we have SSH as our transfer protocol. Or if I talk about transport, then SSH is our transfer protocol. Then data structuring language is XML only. And then data modeling language in the backend is...
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
And data modeling language is YANG, which means that we use SSH. The device needs to have SSH enabled, and based on that, we're going to send some configuration onto the device, which will be written into XML, and then that verification will be done with the data model that exists in the backend with the help of YANG. Similarly, if you look at RESTCONF, the difference is the transport over here is not SSH. The transport over here is HTTP. And the DSL, or data structuring language, is XML, but dominantly JSON. Because RESTCONF came later into the industry, and JSON also came later into the industry as an upgrade or an upgraded version of XML. And hence, you can actually use JSON with RESTCONF, and there is no changes in the backend. Still, YANG data models are used in order to verify the data, which means the only difference that you're going to see is you'll be sending data onto the device by using HTTP, and the data will be written or extracted in JSON format dominantly, though XML is supported over here. Same data models, everything is same. Now, in order to understand that, here are two things, or one thing that you need to understand pretty well about HTTP. Then, when you work with HTTP, you need to be very sure about how HTTP requests work and how HTTP response work. When we talk about HTTP requests, for example, because the communication is going to be done in a way that your you can say your query will be sent. You will set some query, and then the device will process it and give you some reply. In a normal HTTP fashion, we basically have one PC, and then this PC is actually called as client, and this device is called as server. And then we use some applications on the back end, which we can say Chrome or Safari, right? Or Firefox, or even some applications. And by using these front-end GUI applications, we send some data onto the onto the server, which we call it as HTTP query, right? Or HTTP request. And then device processes that query or request and gives you a reply back. That reply is often in the form of HTML page plus JavaScript plus CSS. In combination of this, you actually get a reply, which visually looks so appealing, correct? Now over here, the you can say output is, or the applications that we're using are no longer, I would say, these Chrome, Safari, or Firefox. When interacting with the router with the help of RESTCONF or REST API, the process is going to be similar, but you are on the front end going to use some other applications, and these applications can be Python or Postman, okay, or any third-party application that your company would like to use, but not browsers for sure. And then by using the same, you would also send HTTP query or response, or a query or request. Your router will process that, and then instead of giving you an HTML reply, your boss or your device that's actually acting as the boss, he or it will reply you with the data that is written into JSON, okay, or XML, whatever you want. But mostly we will choose JSON because JSON is easier. The syntax of JSON is just like Python dictionary, nothing else. So if you have any data, for example, written into, I would say, XML, which looks like something like this, like employee. Let's say this is our data, right? And inside of that we have name is AB. Then I close that data with name tag. Then we have, I would say, organization as PyNet. I close that data with PyNet. Then we have role instructed, and we close PyNet. We close role. And over here as well, we need to close organization, not PyNet. We close role, and then we close employee. How would this data be written into JSON? In JSON, you need to open up a dictionary, then specify a key called employee. The value is going to be another dictionary. You can see the indentation. And then there you can say name is AB, comma, next element, organization, PyNet, comma, next line, role, instructor. And when you're done, close this dictionary, that's all. That's how the data would look like. Purely the structure of dictionary. This is the difference between XML and JSON. So of course JSON is easier. You don't have to type all those lines of tags and all that stuff. You can purely work with dictionary syntax. This is how the data will be returned or sent. Once you look at all this data, you first need to then understand how would that request be formed. One important aspect of that particular request is there are almost four elements inside HTTP request. One is URL. The second one is basically the headers. Third is the method, or you can say headers and URL come later. Method is number one thing that you need to understand. and fourth is the body. So when we talk about method into HTTP, if you remember that there are almost operations in netconf which we call as get config and edit config. Over here you can relate to the same. So what we do is method over here into RESTCONF or REST API is same. Get, then you have post, get is your first method, then you have post as your second method, then you have put as your third method, and you have delete as your fourth method. Okay, what does get do? Get fetches out operational or configurational data. Both. In netcon there are separate functions for each of these, but over here there are no separate functions. One function or one method called get fetches out the entire configuration, be it operational or config. Post, however, deploys new config. Put modifies the existing config. And delete deletes the config as the name says. Of course, there are many others as well, but the one that we're concerned about are only these methods, which basically goes onto the device and does some operations. So if we want to fetch out like list of interfaces like we do, we will have to execute a get operation. So these are kind of the operations that you need to perform. Once you perform these operations definitely needs to be performed on a specific device or a specific resource. So the resource over here in HTTP gets identified with URL only. Now over here, you need to point out to that RESTCONF server onto the device, and then use a specific intention about what kind of configuration that you need to do. For example, we want to do the interface configuration that we generally do. So what would that URL look like? There is a specific, I would say, format that is available. First, you use HTTP : / which is going to be constant, right? Then you specify the method before that. This is one. Then you specify your URL. Okay, or in that URL that is broken down into parts. That very first is going to be the IP address of the device, : if there is any port on which RESTCONF has been enabled. By default, it is going to run on 80 and 443. / you specify RESTCONF as constant. Okay, whatever values that I'm given in brackets, these are changeable values. Whatever values that I'm not giving in brackets, it means that that's part of the URL statically. So RESTCONF / data. This basically points to RESTCONF server or service on the device. It is not going to change. And then / you basically give the name of your data model. Okay, and then : container. So if you look at an exact, I would say, URL, that would look something like I want to execute a get operation against HTTP s : / maybe our router is 10.255.1.101. By default, it will go to 443 / RESTCONF / data / IETF - interfaces Over here, you don't need to use any namespaces or something, just the name of the data model. ID of interfaces, colon interfaces, the name of the container. And that's going to be your URL. This is going to give you the list of data models over there. Make sense? That's how URL is basically constructed over here. After that, what's going to happen is you are basically going to work with how the data actually can be fetched out. But for that, you also need to pass some headers. So what are headers, which are the third elements? So there are two types of headers. Headers are basically in HTTP, headers are some information that you want to let the device know about. For example, you're sending data into XML or you're sending data into JSON. This information needs to be known by the receiving party. So this information cannot be part of your request. That's why you need to send all the extra information that you want to send, like the language that you're learning, the time zone that your device is using, the browser that you're using. All of this information in HTTP request is sent as headers or in the header information. So likewise, for letting the device know whether we want to use XML or JSON for the communication part, we specify that intent over here. So there are two type of headers that we use in RESTCONF. One is called as accept header, and the other one is called as content type header. Okay, either accept header or content type header. When we use this accept or content type header, then the values that we can use as a part of them can be application /yang -data plus either you can say JSON or you can say XML. I mean, same will go for XML, like application /yang -data plus JSON or application /yang -data plus XML. You can use any one of these as your accept or content type. Now, when to use accept and when to use content type? The motive of using accept is basically to specify the language that we are expecting the data to be returned out to us. Okay, like in what language do we want to accept the output? If I say JSON, the device will give me the data back to me in JSON. If I say XML, the device will get the data back to me in XML. So this particular header is basically used when we perform mostly get operation. When we perform get operation, we are expecting data to be returned out from the device, right? And that's when we are going to use accept header. And when we are sending the device data, we are sending the data to the device by using this post, put, or delete. Then in that case, we basically use JSON as our operator, or JSON as our you can say payload, right? So in that particular case, I will use content type to let the device know that in which language I am sending the payload to the device. That's the use cases of both of them. And then body is nothing but the data that you want to send. So you will write down your payload into your XML or JSON, whatever, primarily JSON only, and then send that data. This is how HTTP request actually works. Questions? Now talking about the same, there is also something that you know about HTTP requests. Sorry, HTTP response. Let's say your request was processed successfully, and then you get an HTTP response. In that response, there is going to be an important element. 2 parts are going to be there. One is going to be something called status code, and the second one is going to be the body, out of which body is just our data that is going to be returned to us by the device. But status code indicates or gives you a signal where your data was or where your request was successfully executed or not. So there are 5 types of status codes by which you can understand whether it was a successful execution or not. One, there is a status code in the series of 100. 2, there is a status code in the series of 200. 3, there is a status code in the series of 300. There is a status code in the series of 400, and there is a status code in the series of 500. When you get a reply from the device that indicates status code as 100, 101, something, this series belongs to informational category, which means the query was executed or not, or what was the reason behind it. All information will be given to you in this particular type of reply. And I've barely seen this. Okay, I have not seen. I mean, whatever script that I've written, I've only got 100 once or twice in the 2.5 years of my experience. The 200, however, implies success, which means your query was executed successfully. So the reply can be 200, 201, 204, something like that. That indicates that all is good, your query was executed successfully. 300, however, specifies resource redirection. What does that mean? That means that the resource that you're trying to communicate to no longer is available onto the same link, on the same URL. You need to use a different URL for this resource. 400 is something that indicates client error, which means there is an error inside your query. Please fix that. And 500 means there is a server error, which means the RESTCONF server is not responding correctly. Please fix your server first, or ask your admin to get in touch with the server and try to fix that. That's how these things works, or that's how the replies actually works over here. Make sense? Any questions? All good. So let's see and how communicate out. Now here's another, I would say, explanation from my side. What is the difference between RESTCONF? Because everything that we discussed is same for REST API as well. In the RESTCONF versus REST API explanation, what I can see, RESTCONF basically is executed on devices on which Yang data models are executed, or Yang data models are present, which means iOS XE, iOS XR, and XOS majorly. And REST API is executed on all the devices that has a GUI access to it. GUI access devices, which means the solutions like SD-WAN, which actually has a controller, the solution like ACI, which actually, because over here you use a GUI called vManage. Okay, in ACI we use a GUI called Epic. In ASA we use a GUI called ASDM, Application Security Device Manager. So all the devices which can be configured via GUI, okay, those devices can be communicated with REST API, with RESTCONF, not REST API, because RESTCONF uses, oh, I'm so sorry. Over here, this should be REST API. Over here, REST API can actually be used in order to communicate with that particular. When we work with that, the only difference is every vendor over here, SD-WAN or vManage or Epic or ASDM, they will have their own set of documentation, because there are no data models that are present over here. Yang doesn't work over here. So when we talk about the transport stack or the protocol stack of REST API, the protocol stacks looks in a way that it uses HTTP for the transport. It uses XML or JSON, same, but instead of using Yang, it uses or you can say it depends on the documentation. So for every, I would say, product, there will be a REST API documentation that company will expose on, and it is available publicly on the internet. Okay, and by using that particular documentation, you can create some configuration, delete some configuration, or something like that. So there is no data models that comes into picture. You need to follow the documentation in order to create a correct query and get the correct response. That's the only difference between RESTCONF and REST API. Otherwise, everything is same. So we will basically be configuring our RESTCONF onto our device, and then we will be working with two applications. One is Postman, and the other one is Python. Postman is just the GUI way about how you can execute a RESTCONF query, and then same can be executed by Python as well. So let's see. That basically wraps our RESTCONF and REST API theory. Everything is going to be same since here, and let's see how that works.